Really hoping that the sound works now because this is my fourth video because the sound wasn't working. So I'm thinking if I point towards you and talk, it's going to work. So, okay, integrating exponential functions is what we're going to look at. I'm going to be back because I'm not going to talk while I move because it didn't work before. Okay, so these are different to integrating polynomials. And what I mean by polynomials is if you have x squared, anything with x cubed, a linear, any of them, the rule applies for integrating. You add 1 to the power and you divide by that new power. When it comes to exponential functions and trig functions, they go by the rules on page 26 of your formula book. So with exponential functions, for example, e to the power of x or 2 to the power of x, any of these ones where your unknown is in the power, there are certain ways of doing this. So the first, I suppose, and the most common one is going to be with a base of e, okay? So what we're going to, sorry, you'd think I'd know how to this now off by heart after doing it 4 times. Yeah, so I'm just first going to go up to the board and I'm going to write stuff down and I'm going to come back and talk because I'm hoping that will make the sound be okay. So this is from, as I said, page 26 of the formula book. Okay, so right, I'm just going to look at these for the purpose of this. There's another one that sometimes comes up and it's also on page 26 and it's where you have a to the power of x. A could be 2, 3, 4 to the power of x. And in your formula book, you will see how to do that. But I'm just going to focus in on these because e to the base of e is a popular enough one. So to demonstrate this, and just hopefully you can hear me, you can see that if you integrate e to the power of x, it's the same. It doesn't change, and that's the same as if you differentiated it. It's the same. Whereas if you've e to the power of ax, if you think back to differentiating that, you would have left it as it is, like it becomes e to the power of ax and you times by a. So now we're doing the reverse of that. We're dividing by a. We're dividing by the derivative of whatever is in the power, okay? And adding on your c. So I'm going to do on page 73, I'm going to do question 1, part I. Okay, this question asks you to integrate 2 e to the power of 4x dx. First thing to note here, see this 2, you don't have to do anything with this. In fact, you can even bring it out in front of the integral if you want. Nothing's going to change to that. It's this bit we're interested in. So if I integrate that as per this rule, it's going to be 2e 4x over, and you see the way, oh, sorry, see the way up here it was 1 over a. Basically, you're dividing by whatever's the coefficient here, or the derivative of this bit, which in this case is a. In this case, it's going to be 4, so I divide by 4, plus c. That will simplify to e to the power of 4x over 2, because 2 over 4 is a half, plus c. Okay, so what I want you to do now is do question 1, 2, and 3 to get used to using these exponentials.